So we have f of x, which is 1 minus x divided by 3 plus x. Of course, x does not equal negative 3, will be not in the domain. And then find the equation of the tangent line at a point P, comma, P, F, P, negative 1, comma. So when I plug in negative 1, I get 2 at the top and 2 in the denominator, so this is 1. So I'm asked to find the equation of this the tangent at P, which will be y minus y1 equals the slope times x minus x1, where x1 is negative 1 and y1 is 1. And the only thing that I'm missing is the slope. So I'll come back when I'm done with the slope. When I find the slope, I'll go back and find the equation of the line, of the tangent line at P. There is only one definition for f prime of x, which is the limit as age approaches 0 from the difference quotient f of x plus age minus f of x divided by age. You could, if you wanted to, this is just a habit of mine, you do not have to adopt it, but I really don't like the fact that this function is presented with a negative leading coefficient and it's kind of twisted. So I'd rather use this instead. I factored out negative 1 at the top. I put it in front. Now the numerator is x minus 1 because I factored out negative 1, and the denominator is in the correct order, descending order, as x plus 3. Do you have to do this? No. It's just that I'd like to keep everything as neat as possible. And this is what I like. The x minus 1 over x plus 3, even if it has a minus in front, which is okay. So then when I put it in, I will have minus in front, but that's okay. X plus age minus 1 over x plus age plus 3. Now you have to be careful though, because the next step is negative f of x, but that's okay. I'm going to have plus. So plus x minus 1 over x plus 3. And everything divided by h. In the next step, I will find the least common denominator. Help me here if you have anything to say, please. I want everyone to do very well on this test and moving forward. The first test is very important for me, for you, right? So the least common denominator is definitely the product of these two factors. Remember, we will never multiply these factors. We will never distribute them. We want the denominators to be factored at all times, if we can, if we have them factored. That's how we want them. Then I'm going to have to find the adjustments for the numerator and the adjustments for each. This is x plus 3. This one needs an x plus h plus 3, exactly what it does not have in the denominator. So remember what's the concept here. Just simply adding fractions. This was multiplied by this, therefore the numerator has to get the same factor. This was multiplied by this, therefore the numerator has to be multiplied by the same factor. And now very carefully, remember there is a negative sign in front of the first one. So when I distribute x and 3, I change all signs. And yes, you're going to watch me run out of room, like always. So this is negative x squared minus x age, but plus x, minus 3x minus 3h, but plus 3. I already ran out of room. So now I will distribute x to these 3 and negative 1 to those 3. So x squared plus x age plus 3x, but minus x, minus age, and minus 3. Before I even look at this, I need to remember what has to happen for sure. Because otherwise, this is my all these steps that go through my mind, if you want. At each step, I ask myself, am I on the right, not doubting myself, but I'm asking myself, am I on the right track? What am I doing next? Okay, so all terms without age must go away. It's a bonus if more terms, not just those without age, go away. That's fine, but at least those without age must go away. So I see the negative x squared with a positive x squared. I see it in a positive x with a negative x. I see negative 3 with positive 3. Here's a bonus, x age, negative x age. Here's another one, positive 3x with negative 3x. And the top is basically stripped down to negative 4h. There is nothing else. So I will write negative 4h over all this, but times 1 over h, because h is h over 1. This is a fraction. So I copy the numerator, and I multiply it by 1 over h. In the meantime, please do not drop the limit operator. So, negative 4h over x plus 3, x plus h plus 3, times 1 over h. You have to put some sort of parentheses, nested parentheses or brackets or something, because we would really want to separate the limit operator from the negative sign. And now this is the second thing that has to happen, mandatory, unless I'm not on the right track. This has to happen. At this point, after I simplify h, this was the second thing, right? All terms without h go away, and then h from the denominator goes away. At this point, I can drop the limit operator. So what do I write? What is the final simplified form?
Negative 4 over x plus 3 times x plus h plus 3.
Careful. You're very close.
X plus 3 squared.
Yes. Negative 4 over x plus 3 squared. Is that clear, Vicky?
Where do we use the h on the bottom? I mean, I know we have to. H, that's right, h equals 0. So
No, it does not.
Or it's approaching 0.
Exactly.
That's right.
That's the reason why we drop the limit operator. Otherwise, I can't.
Right.
If I still have h in there, I cannot drop the limit operator. I drop the limit operator because I replace h by 0. Is this okay so far? Okay, so we determine the slope. Basically, we determine the derivative of f of x. This is the derivative of f of x. Now we need to determine the slope at p. What do I have to find in order to what do I have to do in order to determine the slope at p? The slope, oops, that's not a good color, sorry. The slope of the tangent line at p must be f prime of negative 1. Very good. F prime of negative 1 must be the slope at p. So can anyone tell us how much is f prime of negative 1? This is f prime of x. How much is f prime of negative 1? Careful, one more time. Oh, there is a negative in front. You're right. I'm sorry. I forgot about that negative. It was just under my nose. My nose was too long. I couldn't see around it. Of course, it's negative 1. All I have to do now is go back here and replace everything to get the equation of the tangent line. So I determined the slope at negative 1 is indeed negative 1. So now I write y minus 1 equals negative 1 x plus 1. One more time, it was y minus 1, negative 1 outside, and x minus negative 1, which is x plus 1. And then we have negative x, negative 1, I have to bring positive 1. So finally, this is the equation of the tangent line to the graph of f of x at the point p coordinates negative 1, comma 1. Yes, please, go ahead.
Would it be y minus y1 equal to y minus negative 1?
Yes, but it is minus minus 1, because x was negative 1. X minus negative 1. Is
I'm
that,
talking about the other side.
oh, okay. So this is y minus 1. Y minus 1 equals negative 1, x plus 1, negative x, negative 1, but then I have to bring positive 1. So these two go away.
I was just curious as to where you got the positive.
Oh, I have to move negative 1 to the other side. Is that okay? I have to solve for y. So I'm adding 1 to both sides. So when I move negative 1 from one side to the other, it becomes positive. Better? I'm not sure I answered your question or not. Oh, well, maybe there is an error and I don't see it. What did you have in mind?
Where it says y minus 1, I have y minus negative 1.
But this is not negative 1 because the y coordinate, we did not write the y coordinate. But when you plug in negative 1, you have 1 plus,
So this-
yes, yes. It's
Right.
f of negative 1, which is 1. Is that okay?
Yep.
So when we plug in negative 1, the numerator is 2, the denominator is 2, that's why we get 1 here. Better?
Yep.
Excellent.
I plugged it in for the wrong.
I'd rather go back and check. A long time ago, I had one of my colleagues, he retired, I don't know, 15 years ago, and he still remains a very good friend of mine. Extremely good professor. I even sat in his class for the entire semester before he retired. And I remember he was kind of my mentor when I got hired 24 years ago. And one time I went to him almost in tears and I said, Gary, I made an error. I was writing at that time on the board. So from this side to that side, I copied something else. I continued the problem without copying correctly. So he said, okay, fine. You showed your students you're not a robot. He was cheering me up. But then I finished the problem with the wrong thing because I didn't copy it correctly from this side of the board to that side of the board. So I had to go back and erase everything and start from scratch. Okay, any questions on this? Okay, which topic do we continue with?
Can we do number 1?
Yes. Any questions on this problem? Is this okay? Okay, perfect. So in number 1, we are given s of t, which is 3 sine t. So we're asked to find, it says complete the following table with the appropriate average velocities. So we're given the function and we're asked to find the average velocity between pi over 2 and pi. And then as you see, everything gets closer and closer to pi over 2. So the interval pi over 2 to pi, and then pi over 2 to pi over 2 plus 0.1, and then pi over 2 to pi over 2 plus 0.01. So we're getting closer and closer, closer and closer to pi over 2. So I will create a table with t. This is pi over 2, and this is the slope, of course, of the secant line. So this is pi. The next closer will be pi over 2 plus 0.1. The next one will be pi over 2 plus 0.01. The next one will be pi over 2 plus 0.001. And the closest one will be pi over 2 plus 0.0001. I'm not going to do this by hand. I'm just going to create a function that gives us the slope of each and every secant line. The one between pi over 2 and pi, and then closer, and then closer, and then closer, and then closer. So,
Oh wait, so the one in here, it just says 0.00. Is that just supposed to be 0.001?
oh yes, please correct that. Of course. They are in order, closer and closer. Thank you. Okay, so it's very clear everything gets closer and closer to pi over 2. So let's create the slope of the secant line. So that will be s of t minus s of pi over 2, because pi over 2 is our reference point. All of these intervals have pi over 2, over t minus pi over 2. This is what we are going to enter in the graphing calculator. Any questions so far? So let's put it in. as we see it. Of course, I will replace s of t by 3 sine t. So 3 sine t. What about s of pi over 2? Can anyone give us s of pi over 2? Very good. So it's minus 3 over t minus pi over 2. Perfect. This is the function we put in, and we will replace t first by pi, then by pi over 2 plus 0.01, and so on and so forth. You cannot replace t by pi over 2. Ready? In y equals. Make sure your mode is in radian mode. I'm assuming mine didn't change. It's not. It's still in radian mode. Okay. Parentheses for the top. Parentheses 3 sine t. We don't have t. We have to put x minus 3. Close the parenthesis and divide in parentheses by t, or in other words x, minus pi over 2. Is this okay so far? Everyone, can you follow? Okay, now we go to second and table. I have to check if this, yes, it does change my settings here. So second and table, we will plug in pi. We will plug in, and you don't have to calculate anything. Pi divided by 2 plus 0.1. Then we plug in pi divided by 2 plus 0.01. The next one, pi divided by 2. I didn't mean that, of course. Pi divided by 2 plus 0.01. And then pi divided by 2 plus 0.001. And I think we have one more, right? Yes, one more. Pi divided by 2 plus 0.0001. If we want to be as close as possible to see what this comes up to be, let's see if I get even closer. Let's see what we get. 0.000001. Okay. So what is this number? Negative 1.5 e to negative 6. Okay, so let's get even closer if we don't have an idea. So pi over 2 and plus point, I don't know how close I can get. We'll see in a moment if it gives me an error or it gives me the final answer. So what is negative 2 times 10 to negative 6 then? Close to 0. So what would you say about the slope of the tangent line at pi over 2? We will be able to determine this very easily. I will show you a tool that appears in chapter 4, but I will not wait till chapter 4. We need that tool as soon as possible. So we're going to use it in chapter 3, but not yet. We can't just yet. We don't have all the information yet. So any questions? So in the table, please put in those numbers. So put in negative 1.91, negative 1.41, and so on and so forth. And then eventually we'll write that the slope of the tangent line is 0. And you will see why. Good. What do we continue with? Next question, anything you like from the list?
Oh,
Anything?
we do like,
Which one?
number on page 3.
This one? The limit with the square root? Okay. I think we had one, but it's a very good point. Very good idea to look at another one. And this is the limit. The square root of 4 minus x squared when x approaches 2 from the right.
You have to find the domain.
Yes. So what do I have to write in order to find the domain first?
Like your sine graph. X has to be greater than 0.
I would say yes if the square root were taken from x. If the square root is not taken from x, is not applied to x. The square root is applied to.
Oh,
Good. So then what do I have to write?
1 minus x squared has to be greater than 0.
Of course. Excellent. So yes, that's the idea. The square root has to be taken from positive or 0. Whatever the radicand is. If the radicand is 4 minus x squared, this quantity has to be greater than or equal to 0. If I have plus 5 outside, for example, that has nothing to do with anything. Still, the quantity under the square root has to be greater than or equal to 0. The positive 4 or 5 does not affect the domain. Good. So what type of inequality is this?
Quadratic.
Very good. Perfect. So how do I solve a quadratic inequality?
You move the 4 to the other side of the never,
Never.
right?
Yes, I would have said absolutely correct if it were an equal symbol, but not in an inequality.
You just remember it.
Yes, but I first arrange it. Remember, it's not cleaned up. I refuse to work with it like that.
At the back.
I will multiply first by -1 and get x squared minus 4 less than or equal to 0. I need to see it arranged in the correct order. I need to be able to simply and easily factor it. I don't want to factor a negative leading coefficient like that. So now I will factor as x minus 2 and x plus 2 less than or equal to 0. And then use any method you like to study the sign of the product. This is the method I like because it's easier for me to explain what I'm doing instead of just plugging in numbers like the method in the book. But there's nothing wrong with that method. If you understand it, if you like it, use it. So this is a table that will allow us to study the sign of a product. The table does not work if this is not a product or a ratio and 0 on this side. If I don't have 0 on this side and this is not a product or a ratio, the table means nothing. It's not going to give us any information. So x is the variable in the problem that goes from -infinity to infinity. And now each of these factors has a 0. Each of these factors has a number where it is 0, where its value is 0. Which numbers am I talking about? So for this one is x equals 2, and for this one is x equals -2. They have to be arranged in a correct order, ascending order from left to right. Then I will put the zeros. 0 and 0, and 0 and 0. And then I don't have to think much, because both are linear functions with a positive slope, and I know their signs. What is their sign for both of them? From? Right, I know I look silly, but maybe this will trigger your memory, right? So you don't have to plug in numbers. You can if you want to. Obviously, on this subinterval, I multiply two negatives. That's what I'm doing. Here I multiply a negative and a positive, and here I multiply two positives. because this is the product. This is the product of these two factors. So therefore, the domain of this function is indeed, that is the domain. Because this symbol tells me that I have to choose x values that make this product negative. Only those numbers make the product negative. Anything outside will make, all numbers outside of this interval will make the product positive. So knowing that that is the domain of this function, now I can answer the question. It says, find the limit of blah, blah, blah as x approaches 2 from the right. What will you say? My cheap markers are drying up.
It's not infinity, is it?
2 from the right. Thank you. Function doesn't even exist on the right-hand side of 2. How can it have a limit? Although, sometimes functions have limits when they don't exist, right? But the function does not exist at all. It does not, there is no trend. The function is non-existent to the right, to the right-hand side of 2. Non-existent, so it cannot approach any number. Very good. Next question, please. I hope you recognize this one. You had it on the quiz. Which one? I'm sorry. Vicky, sorry. Or Sabrina, I'm sorry.
Can we do 2F?
Yes, 2F. Yes. Very good. I'm looking for a second to see if I copied this from chapter 3. Because if I copied this from chapter 3, I can't remember right this second. So just give me 1 second to look at if we, yes, I did. My apologies. This will not be, this is in 3.3. My apologies. So you can strike that. So this is not part of this chapter. I can show it to you, however, of course. But it will come up in the next chapter, in chapter 3. My apologies. So this is from chapter 3. I thought that something wasn't right because we have not talked about it. So I said, I think I copied it from chapter 3, and I did. Good. Sorry about that. It will come back in chapter 3, section 3.3. Good. Anything else you would like to see?
Number 3.
Yes, number 3. Perfect. In number 3, we are given a piecewise defined function, and that is f of x, x squared minus 5x for less than or equal to -1, and cx cubed minus 7 for x greater than -1. The problem is asking us to determine c, the parameter, such that this function is continuous everywhere. What is the starting point? What do we need to do here?
Well, first you have to write out, the limit of f of x.
So first of all, I have to explain that x squared minus 5x and cx cubed minus 7 are This is extremely important. That's the first step. I have to recognize what type of function this is. I have to recognize what type of function this is, and I have to write this. Yes.
First one's continuous.
Excellent. So these are continuous functions since they are polynomials, period. And we know that polynomial functions are continuous everywhere. Perfect. Now the next step is indeed continuity at x equals,
Negative.
that's it. And now I have to write a definition of continuity.
It's the limit of f of x.
The limit as x approaches -1 from the left, and I should put that particular branch, must equal limit as x approaches -1 from the right, and I should put that particular branch, and that must equal f of -1. This will be good enough. You can write a definition as the general definition first if you want, and then plug in this, but you will be writing it twice. This is sufficient to me. And if you put the correct branch here and the correct branch here, I know you know the definition of continuity at the point, and that's all I care about. So then, what do I have here?
X squared minus 5x.
And of course, the other one, 5x cubed minus 7. And how much is f of -1? And which branch will you pick? Because you can only pick one. Top? Top. Very good. So then when you plug in -1, you will have 1 plus 5, which is 6. Would you agree with 6?
Yes.
Perfect. And then what is this? And what is this? How many parameters or unknowns, if you want, we have here? How many parameters? 1. How many equations we need? 1. Good. So please tell me what to write. The left-hand side is definitely I can let my
1 plus 5.
and the other one is
C -1 minus 7.
good. So then, bless you. A negative c equals 13, so c equals -13. And now I have to write the function from scratch. So f of x equals x squared minus 5x for x less than or equal to -1, -13x cubed minus 7 for x greater than 1. And what do you say about this function? You know something about it, which is continuous on -infinity to infinity. So I think this should be okay. This is the third problem similar to, right, to this. Yes,
Sorry, I'm just reading.
you may see something I don't, very possible.
No, I'm just looking through the process of that C. So you just brought it over, you swap sides with the -c and the 6, right?
So I added 7 to both
Alright.
sides, I got 13, and then I get
And you just
divided both sides by -1. Or multiply both sides by -1. So this function is guaranteed to be continuous everywhere. Right? Everything okay? We had 3 problems like this. Yes, everyone? Any questions, please? Any questions? Okay, so please continue. Which one?
2H.
Which one?
2H.
2h. Very good. So in 2h, limit as x approaches -infinity from 3 tangent inverse plus 2. When we think about tangent inverse, we should see the graph. And where does it go when x approaches negative infinity? What does it approach when x approaches negative infinity? Arctangent. Arctangent approaches what when x approaches negative infinity? Negative pi over 2. Awesome. Very good. So then the limit is negative 3 pi over 2 plus 2. Very good. Okay. Do you remember the graph of arctangent? Should I graph arctangent again? Yes?
Yes.
Yes.
Please remember, it should be in your notes at least twice. Y equals pi over 2, y equals negative pi over 2, and this is arctangent x. These are crucial functions, very important, so moving forward, please remember them. E to the x, natural log x, arctangent, tangent. Okay. Good. Anything else from here? Yes?
Could you add one right here?
Which one?
To I think,
Yes, the limit e to 1 minus x.
is that just e 0, so it'd be plus, or it'd be 1?
So let's take a look. So limit as x approaches infinity, e to 1 minus x. Good. So yes, because it's negative infinity plus 1, which is still negative infinity, will be 1 over e to infinity. So this is basically 0, which means y equals 0, horizontal asymptote at infinity. Careful, this is not a rational function. It doesn't have to have the same horizontal asymptote at both sides, as long as it's not rational. If it's rational, it has to have the same horizontal asymptote at both sides. Okay, next question. Anything else, or I make something up? Yes.
Just number 2A.
2a. 2a, let's take a look. In 2a, we have limit as x approaches 2, 3x squared minus 7x plus 2 divided by 2 minus x. Good. Now you already know that I'm going to rearrange this most of the time, approaching 2. Okay, so what do we do first? Always? Plug it in, very good. So please plug in the 2 at the top. 0. Please plug in 2 at the bottom. So what is the culprit that I know creates the problem?
X.
Which,
X minus 2.
very, very good. Knowing that, see how important this is to have knowledge of what's happening? Once you know what factor creates 0 over 0, you can already put it in. So now the whole thing is much easier. And what could you say about the second factor? What is the second factor? Very good, let's check. Very easy to check. So 3x squared minus 6x minus 1 -7 and +2. So how useful the remainder theorem and the factor theorem are. You plug in a number in a polynomial, you know you get 0. Therefore, you know at least one of the factors. Extremely useful, right? If you plug in -5 into a polynomial and you get 0, which factor is already must be there? Which factor? If you plug in -5 and you get 0.
X plus 5.
Exactly. I plugged in 2 and I got 0. There is an x minus 2 in both. Otherwise, I would have not gotten 0 over 0. Good. So, of course, the problem goes away. And the final answer is, so we have 3 times 2 is 6 minus 1 is 5, but there is a minus in front. -5.
So for this one,
Yes?
would you have been able to just take the derivative of the top and the bottom to get 2 minus 7?
Excellent question. We don't know what that is, and we don't know differentiation rules,
Okay,
and we haven't talked about L'Hopital's rule yet.
okay. No, I wasn't sure.
You can check it if you know it. You can check it on scratch paper, but I can't accept it today or Thursday. But yes, of course. Only because it's 0 over 0.
Right.
Otherwise, and the second option is infinity over infinity. In no other case you can apply L'Hopital's rule.
Okay.
Very good question. Anything else? Number 9. Very good. So we have limit as x approaches 1 from 5x minus 2, and they say it's 3. We should always check. Yes, 5 minus 2 is 3. They want us to use the epsilon delta definition. So this is equivalent to saying for every epsilon positive, I will find the delta positive such that every time I pick, then I get this. What am I referring to? And from another class, a student asked, okay, show me an example, where will this be useful? Here's where it will be useful. So let's suppose we're manufacturing, for example, discs. And those discs have to have a certain area. So the question is, if there is an error in the area of the disk, what is the error in the radius of the disk? What is the acceptable error? So if there is an error in the area of the disk, what is the acceptable error around the radius of the disk? That's an example of when we would be looking at epsilon and delta. Okay, so then what do I have here?
5x minus 2.
Not there, but here.
And, minus 3.
It's not less than epsilon.
Perfect.
Isn't that just f of x minus, or no? sorry,
We're talking about
minus
x. Which is
1.
x minus 1 indead. Very good. We start from the end. So this is 5x minus 5 less than epsilon. The only thing we can do is factor out 5. And then this is the absolute value of 5, and x minus 1 less than epsilon, which is 5, times the absolute value of x minus 1. And then x minus 1 in absolute value is less than epsilon over 5, which cannot be anything else but according to this. What can it be? Thank you very much. And now in step 2, I have to write that I have to reverse the steps. So in step 2, so this was step 1. And in step 2, show that delta equals epsilon over 5 works by reversing the steps from above. Which you do not have to actually do. Next question.
Seven.
Okay. So we are given x to the 5th plus 7x plus 5 equals 0. We're asked to use the intermediate value theorem to show that there is a solution somewhere. So x to the 5th plus 7x plus 5 equals 0. So and this is f of x, which is x to the 5th plus 7x plus 5, which is a function that is continuous everywhere as a polynomial function. Now I only have to determine an interval. So let's determine an interval. So in y equals plug it in. We have x to the 5th. And then plus 7x plus 5. Okay, I see here that, I can cheat. It's okay. I'm looking at the graph, so I know I see that the solution is somewhere between -1 and 1. So I'm going to plug in. It's okay to look at the graph, of course. So I'm going to plug in -1. I'm going to plug in 0. I'm going to say that's it. I'm not asked to determine more than one interval. So I found that the solution, at least one solution, is somewhere between -1 and 0. All I have to write is that f of -1 is negative, and f of 0 is positive. Since the function is continuous everywhere and it changes sign between -1 and 0, I would write, therefore, from these two conditions, continuous, of course, in this case, I'm talking about -1, 0, but this function is continuous everywhere. It's a polynomial function. And f of -1 is negative and f of 0 is positive. By IVT, there exists a C in the open interval -1, 0 such that f of C must be excellent. So remember, the intermediate value theorem does not give us the solution, but it tells us that there is one. And this is extremely useful when we get to chapter 4 to Newton's method. You will see we will start with that.